बच्चों फिजिक्स के लास्ट चैप्टर 15th चैप्टर वेव की समरी पढ़ के सुनाती हूँ आपको। मैकेनिकल वेव्स कैन एग्जिस्ट इन मटीरियल मीडिया एंड आर गवर्न्ड बाय न्यूटन्स लॉज. Transverse waves are waves in which the particles of the medium oscillate perpendicular to the direction of the wave propagation. Longitudinal waves are the waves in which the particles of the medium oscillate along the direction of the wave propagation. Progressive wave is a wave that moves from one point of medium to another. That is, displacement in a sinusoidal wave propagating in the positive x direction is given by y xt is equal to a sine kx minus omega t plus phi, where a is the amplitude of the wave, k is the angular wave number, omega is the angular frequency, kx minus omega t plus phi is the phase, and phi is the phase constant or phase angle. Wavelength omega of a progressive wave is the distance between two consecutive points of the same phase at a given time. In a stationary wave, it is twice the displacement between the two consecutive nodes or antinodes. Period t of oscillation of a wave is defined as a time any element of the medium takes to move through one complete oscillation. It is related to the angular frequency as through the relation t is equal to 2 pi upon omega. Frequency nu of a wave is defined as 1 by t and is related to angular frequency by nu is equal to omega upon 2 pi. Speed of a progressive wave is given by v is equal to omega upon k or is equal to lambda by t or equal to lambda nu. The period of a transverse wave on a stretched string is set by the properties of the string. The speed on a string with tension T and linear mass density mu is given by V is equal to root T by mu. Sound waves are longitudinal mechanical waves that can travel through solids, liquids, and gases. The speed V of the sound wave in a fluid having bulk modulus B and density rho is given by V is equal to root B upon rho. The speed of longitudinal wave in a metallic bar is equal to V is equal to root Y upon rho, where for gases since B is equal to gamma P, the speed of sound is V is equal to gamma P upon rho in the root. When two or more waves transverse simultaneously in the same medium, the displacement of any element of the medium is the algebraic sum of the displacements due to each wave. This is known as the principle of superposition of waves. Y is equal to summation of Fi x minus Vt. Two sinusoidal waves on the same string exhibit interference, adding or cancelling according to the principle of superposition. If the two are traveling in the same direction and have the same amplitude A and frequency but differ in phase by a phase constant phi, the result is a single wave with the same frequency omega, as y xt is equal to 2a cos 1 by 2 phi sine kx minus omega t plus half phi. If phi is equal to 0 or an integral multiple of 2 pi, the waves are exactly in phase and the interference is constructive. If phi is equal to pi, they are exactly out of phase and the interference is destructive. A traveling wave at a rigid boundary or a closed end is reflected with a phase reversal, but the reflection at an open boundary takes place without any phase change. For an incident wave, y I xt is equal to a sine kx minus omega t. The reflected wave at a rigid boundary is y r xt is equal to minus a sine kx plus omega t. For reflection at an open boundary, y r xt is equal to a sine kx plus omega t. The interference of two identical waves moving in opposite direction produce standing waves. For a string with fixed end, the standing waves is given by y xt to a sine kx cos omega t. Standing waves are characterized by fixed locations of the zero displacement called nodes and fixed locations of maximum displacement called antinodes. The separation between two consecutive nodes or antinodes is lambda by 2. A stretched string of length L fixed at both the ends vibrates with frequencies given by nu is equal to nv upon 2L, where n is equal to 1, 2, 3. The set of frequencies given by the above relation are called normal modes of oscillation of the system. The oscillation mode with lowest frequency is called the fundamental mode or the first harmonic. The second harmonic is the oscillation mode with n is equal to 2 and so on. A pipe of length L with one end closed and other end open, such as air columns, vibrates with frequencies given by nu is equal to n plus half v upon 2L. The set of frequencies represented by the above relation are the normal modes of oscillation of such a system. The lowest frequency given by v upon 4L is the fundamental mode or the first harmonic. A string of length L fixed at both ends or an air column closed at one end and open at the other end or open at both the ends vibrates with certain frequencies called their normal modes. Each of these frequencies is a resonant frequency of the system. Beats arise when two waves having slightly different frequency nu 1 and nu 2 and comparable amplitude are superposed. The beat frequency is v nu beat is equal to nu 1 is approximately equal to nu 2. Last point is the Doppler effect is a change in the observed frequency of a wave when the source S or the observer O or both move relative to the medium. For sound, the observed frequency nu is given in terms of the source frequency nu O by nu is equal to nu O, nu plus nu O upon v plus vo is equal to upon v plus vs. Here v is the speed of sound through the medium, v0 is the velocity of the observer relative to the medium, and vs is the source velocity relative to the medium. In using this formula, velocities in the direction os should be treated as positive and those opposite to it should be taken as negative. Then there is a table of physical quantities: wavelength, propagation constant, wave speed and beat frequency. Wavelength symbol lambda, dimension L, unit m, and distance between two consecutive points with the same phase. Whereas propagation constant given by k, dimensions L inverse, m inverse, k is equal to 2 pi upon lambda. Wave speed is given by v, L t minus 1, ms minus 1, v is equal to nu lambda. Beat frequency v nu beat, t inverse, second inverse, difference of two closed frequencies of superposing waves. Now the points to ponder you have to read yourself, and there are some exercises. Not too much of sums are given. There are 27 numericals total. So do all the sums and your chapter will be completed. Nice chapter, small chapter.